discussed this climate accumulation, this carbon accumulation, and now we're going to fuse this to the rest of the economy. And there's two things that happen. First is the abatement cost, mu. How is that determined? Well, actually, it's an optimal choice that firms are undertaking here. So firms choose, the firm manager implicitly chooses four things. The firm in the first stage, the firm manager chooses how much to produce and how much labor to use, and then implicitly it chooses how much to emit or how much to abate. Okay? So those are the choice variables that the firm has, and the firm manager chooses these things optimally to maximize profits. And then in the second step, so this is like first stage, that, and then the second stage, the firm manager chooses the price subject to the price adjustment costs. Okay? So price choice subject to adjust to Rottenberg. I'm just going to write Rottenberg, right? So the first, and so what is the production? What's the profit function? That's what we see here. So the firm tries to maximize profits, which is a revenue-based object minus all the costs the firm has. So the cost the firm has is the labor costs, is how much it has to pay its workers. There is a so-called abatement cost, and there is a carbon tax cost. So that's one way to think about this. We're going to discuss the details here, but if you're struggling to think about why these are profits, there's another way, of course. This is equivalent of minimizing costs, right? So if you can multiply through this equation by -1 on both sides, then what you're going to get is you're minimizing the negative here, so this is the negative, and then you're getting all the pluses there. And what this is now is you're minimizing your costs, but you have to keep in mind that you want to produce. Right? So this is cost minimization subject to the constraint that you want to produce as a firm, where MC is the Lagrange multiplier on the production constraint that is going to coincide to marginal costs. Right? It's a standard cost minimization problem. So either you intuitively think about this as maximizing profits, or you're minimizing the costs that you have as a firm, subject to a production constraint where in terms of output, where the marginal unit, the relaxing that production constraint at the margin is just marginal cost. Okay. So then let's go here. The labor cost is pretty straightforward. What are these abatement costs? Well, we discussed that emissions can be reduced by abating, but abating doesn't come for free. Like developing more fuel-efficient engines, developing, putting in filters and stuff like that. So there's a cost, and the authors borrowed this from other papers from Garage and Nordhaus. So these are abatement costs. They are proportional to output. So the more output you have, if you have a big firm or a small firm, your abatement costs are going to be smaller or larger. And then the abatement costs are a function that have a slope term on the abatement, and they have a curvature term on abatement. So the more you abate, notice that if mu is equal to 0, if you do not abate at all, you don't have any abatement costs. But if mu is higher, then there's more costs there. And in general, theta 2 is a positive parameter, so theta 2 is larger or equal than 0, meaning that these are costs that can be quadratic. So if theta 2 is 2, then these are quadratic costs in abatement. Now what is this theta 1 they're doing? That actually has a time subscript also on it. So that's the slope, that's the per unit cost of abatement, right? And what they are assuming, that's another trend. So they have in total 5 trends. It's a little, almost too much, right? So they have population has a trend, productivity has a trend, then the decoupling rate of emissions has a trend, it's number 4. Then they have the inflation target has a trend, and now they also allow this abatement cost to have a trend. With the understanding again that over time it has gotten cheaper and cheaper to put in more energy efficient, the abatement becomes cheaper and cheaper over time. So over time abatement is not as costly. Like developing the first carbon dioxide filter of a factory who burns fossil fuel was much more expensive like 30, 40 years ago than it is today. And that's what this thing captures. There's also a possible trend in that. Finally, the government levies a exogenous tax onto these firms for emitting. So tau is a tax rate that the government decides upon that's proportional to your emissions. So if you emit 1 gigaton of carbon dioxide, the government, you have to pay a tax as a firm of tau E. That's the basic idea. So it's like when I book a plane ticket to Vietnam, that's the cost that is embedded in my plane ticket. In case, so tau can be 0, in which case there is no cost, right? But tau can be also non-zero, and in which case the firm has to pay costs. All right. Now, there is now an optimal choice, and we're going to see that. I'm going to work this out with you later on, but we're going to come back to this. There is now a choice. So if you're the firm manager, let me ask you whether you understand this problem intuitively. Suppose you are a firm, and suppose the government sets a 0 carbon tax. Okay? So suppose you're living as a firm, and the government sets taxes to 0 on emissions. What is your choice on abatement? What would you choose as a firm for abatement? How much would you abate as a firm when there's 0 costs of emissions? 0, exactly. You're maximizing profits with 0 abatement. Why is that? Well, spending on abatement doesn't benefit you at all, right? Why would you, as a firm manager, spend on abatement if it's not going to be beneficial to you? It's just going to eat into your profits. Profits are going to reduce because of abatement spending, but as a firm, you don't have the benefit of it. Right? Society always has a benefit, right? I mean, society would value if we would abate as firms because we would have fewer emissions, but it is privately optimal to not abate at all. Provided there's, so in other words, the optimal choice is all, from a firm perspective, is always to have 0 because that's going to help maximizing the cost. Now suppose the government comes in and starts to have taxes in here. So the government starts to put in a tax on emissions. What is your optimal choice for abatement now? What is your optimal choice for abatement now? When the government comes and taxes you for your emissions.
It won't be, at most I would pay as much as the tax amount.
That's right. Now the firm manager has a trade-off, right? If it chooses 0 abatement, if it chooses 0 abatement, right? Suppose the tax rate is 50%, 0.5, just for the sake of the argument. Okay? So if the firm manager chooses still 0 abatement, even though it has a tax rate, if this is still 0, then there will be emissions produced, and the firm has to pay a tax on these emissions. Okay? So the firm with 0 abatement would have a lot of emissions and would need to pay taxes on a lot of emissions. That's going to cut into the firm's profits. So that is what the firm manager takes into account. Now suppose the firm manager thinks about, let me invest a little bit in abatement. So that's going to wake up this cost. But it's going to reduce the amount of emissions that the firm is going to produce, right? So the abatement cost that the firm now pays is going to reduce the emissions, and so that's going to reduce the tax bill for emissions. So these two things in general, they go against each other in terms of profits, right? They're all eating into your profits, but essentially, the abatement is going to reduce the emissions. So that's the key idea here, that the emissions going up, abatement is zero. Emissions being driven down, abatements go up, abatement goes up. So there's actually a trade-off. And what Nitin just said is that the firm chooses an optimal mix now of abatement and tax payments on emissions. That at the margin just breaks even. That's the idea. That is the key idea. And maybe we can develop this together. So let's develop this together. Let's write down what is the optimal abatement choice. Let's just work this out. So this is the optimal abatement choice. Okay. So let me write down the profit function here with you. So the profit function is we want to maximize the marginal cost times output plus WT times NT plus theta 1 mu T theta 2 YT plus tau E comma T ET, right? So that's the profit function. I just copied the profit function from the previous slide. And of course, we need to take into account that emissions E follow this equation here, right? We need to copy this equation. So this is now sigma T 1 minus mu sigma T 1 minus mu T YT epsilon. What's the name of that?
Sorry,
Epsilon ET.
is it the maximize, so the minus, not the plus?
Got it. Thank you, Juan. Thank you very much. Right. So now these things, of course, I miscopied them. Thank you. That's a great catch. These things now, of course, must be minus signs here. There we go. Thank you. Okay. You rescued me on this one. Okay. Right. And now, of course, we could work out all the choices for Y, E, and N. But I'm just interested in my choice for mu. Okay. So that's what I just want to choose what is now the optimal abatement choice mu given this problem. Okay. And then the first step to do is to plug that into the objective for E. Okay. So we're going to go and we're going to just plug that into this element E there. So I can rewrite this profit function as the maximum of MCT times YT. By the way, can you read my handwriting?
Yes.
Yeah? Let me know if this is too difficult. Let me use my ink here, maybe it's going to be better. Okay, minus, then we have WT NT minus theta 1 mu T theta 2 YT minus tau E comma T times sigma T 1 minus mu T YT epsilon E comma T. So technically we just substituted the emissions constraint into the objective. And now we can already see whether we have a well-defined problem, because now we're going to take derivatives, right?
Yeah.
But before you take any derivatives in your lives, right, always stare at the equation that you want to take a derivative of. And the derivative always must mean that there's two opposing forces, otherwise you get into a corner solution, right? So in other words, our choice variable is mu, and if I increase mu here by the minus sign, this thing is going to fall, okay? So in other words, this is exactly the negative profit effect. Right? If I wake up my abatement spending, it's going to eat into my profits, and that's going to drive down profits here. So that's the down force. Now let's take a picture here, take a moment here. If you wake up your abatement spending here, that is 1 minus it, so that thing is going to fall, and there's going to be another minus sign there, so that's the opposing force there. Any abatement spending is going to eat into your profits because you spend more, but you're saving on the carbon tax spending. Okay? So those are two opposite moving objects here, which give hope for an interior solution. Okay? That's the basic idea. Okay? So in terms of directional responses, right? This one, this object here increases in mu. So if mu t goes up, this thing goes up. Okay? While this one here, this expression, if mu t goes up, this object here, or this parenthesis, this lower brace goes down. And that's great. I mean, it's exactly what we want, right? The idea is that you spend more on abatement, that's going to be costly here, but you're going to save on your tax bill to the government. Okay? Excellent. And now we take first order conditions, right? Now we differentiate this object. So we're going to say the partial derivative of this object with respect to mu. And what is that? Okay. Well, we're going to have to differentiate this object, which is going to be minus theta 1 times theta 2 mu t to the power of theta 2 minus 1, right, times yt. That's like just the derivative of this object with respect to mu t. Alright? And then we have to differentiate this object with respect to mu t. Okay. That's now going to be plus, because I'm differentiating this with mu t, so this is minus gives you a plus, and then we differentiate with this one. Okay. So that's when you're going to have plus tau e comma t, sigma t, yt, epsilon e comma t. And you're going to set that object to 0. Okay. So that's that's the first order condition associated with this problem. Use one more slide deck here for that. Okay. Now you can see. So that's the. Does everybody have that? Now you can get rid of this yt on both elements. Okay. So let me take the yt out on both elements. And then let me also rewrite this. So let me bring the mu on one side of the equation and everything else on the right-hand side of the equation. Actually, I forgot one thing, of course. This must be comma t. Okay, so this is theta 1 comma t. It's theta 1 comma t. And so then this must be theta 1 comma t. Theta 1 comma t. And then also in the first order condition, theta 1 comma t. Alright, so then what I want is I want mu t on the left hand side, and so the way to get this is to bring all this on the right hand side and multiply through, right? So the idea is mu t, optimal abatement, is then nothing else than just tau e comma t times sigma t times epsilon e comma t divided by theta 1 comma t times theta 2, and then the whole thing raised to the 1 over theta 2 minus 1. Okay. Let me double check that there's no glitch here. Right. That looks good to me, right?
Yeah.
So this is now the optimal abatement choice. This is the optimal abatement choice. Okay. And there we see that the optimal abatement choice is a function of the tax rate.
Yeah.
That is the key for you guys to keep in mind. Okay? If the tax rate goes up, firms find it optimal to start abating. When the tax rate is 0, abatement is 0. When the tax rate is positive, abatement starts to go up. That is the key idea. Right? And so then likewise, if for instance if there is a carbon emissions shock, right? Firms try to cope with that by, abating more, right? Ceteris paribus. There is less need for abatement if the technology for abatement improves, right? I mean, theta 1 comma t is this object that is the technology, and if that technology improves, then we're going to get better technology to do that. It's less costly. We're going to wait a second. Let me make sure that is correct. So this is the cost. Oh yeah, if the cost of abatement. Sorry, this is a cost. It's a better. The way I interpret this is the technology of abating. Of course, that reduces the costs of abating.
Yeah.
Okay. So when, in other words, if this in the denominator is falling, if this gets cheaper and cheaper and cheaper to abate, right? That's one how you have to interpret that. Then you're going to have more abatement spending. So each of these elements, to me at least, make a lot of sense intuitively. But the key idea is, without taxes, firms have no incentive to abate. This economy, firms will only abate if you are, taxed. Good. Any questions? So keep that in mind. All right. So I think we understand now all of this in our first part, and now let's get back to what we started before the break, and where you do you want to copy this with the photograph?
I mean the second, yeah.
This one?
Yeah, yeah.
Okay. Yeah. So let's see what is now the production function. So output in this economy is produced with exogenous technology, just as we had in our first, Monday, Tuesday slides. It is produced with labor input, so there's no capital here, or capital is constant. Alpha is between 0 and 1. So alpha is the productivity and marginal product of labor, is the marginal contribution of labor to the production. So alpha is between 0 and 1. And then importantly, what is this phi parameter here? In general, this is a negative function of m. So the more emissions we produce in the production process, the more emissions we have, the higher m is, the lower is this phi. So in other words, this is you should be more careful when I'm writing this minus sign. So this object, this function, is affecting production negatively.
Sorry,
Yeah.
Professor. So the MT is a stock, right? But then when you put it, the pi as a function of MT is become the carbon cost, is it?
Can you say that again? Sorry.
No, the MT is a stock variable. It's
That's
a measure is the amount
Yeah.
carbon you have, right?
Right.
But then when you put it into the pi as a function of MT, utility,
Yeah.
it means that whole thing is the cost of carbon, is it?
Yes, it's the cost of carbon in terms of reducing productivity. Okay, so think about if carbon is at its 1750 level. Okay, so if carbon is like the pre-industrial revolution level, then if you stick that in here, and suppose that number is 1. Okay, so suppose you stick in M 1750, and that generates phi, you can make that, so phi of 1700 m of 1750, suppose that's equal to 1. Suppose that's equal to 1, okay? Then, the production function looks like it's Ct times 1 times n to the alpha. And now, you stick in a level of carbon that's bigger than in 1750. Okay? So then, phi of, say, m that's large, and mt that is larger than m of 1750, that is going to be smaller than 1. That's the idea. Okay? That when carbon exceeds that pre-industrial, level of carbon, then that's going to reduce the productivity by which, the economy operates. And the idea is that, well, you can think about that, you have more recurrent droughts, flooding, and that reduces how productive this economy is. Okay. All right. So then, how how do they, what's the functional form they are using, right? I mean, this was just an example, right? So this is like suppose, right? The particular example or functional form they are using is they're using an exponential function. They're using an exponential function that these damages, that's why it's called a damage, because it negatively affects production, right? It negatively reduces the amount of output. For the same amount of hours, you're going to get less output. And so the higher the stock of carbon is, via this minus sign, the lower is that thing is going to be. Okay? And in this literature, this parameter gamma here is called the damage parameter. So the gamma is a positive number, right? And so for every ton of carbon in the atmosphere, this is producing e to the power of minus gamma reductions in this. So if m is equal to 0, you immediately see this is equal to 1, right? So suppose this is equal to 0, then it's going to get exactly our numerical example. So if m is 0, then you have e to the 0, that's 1. And then if m is larger than 0, you're going to have emissions. Now, of course, in 1750, there was carbon in the atmosphere. So that example doesn't bite, when m in 1750 is not usually for this particular functional form. But you get the idea of how to think about this, right? Great. Any questions on this? Now let's take a look at what happens in this economy now to our beloved little, I say beloved, to our little equation, okay? So now very importantly, this is how the economy now looks like without abatement or no carbon taxes. So here we're just going to learn what does the climate change do to the economy. Okay, so let's write this down. So here is going to be no carbon tax. There's no carbon tax. So tau E comma T is equal to 0 for all T's, right? And what does that imply for the abatement? The abatement is going to be what? 0 all the time. Okay, so that also means mu T is equal to 0 for all periods in time. Okay, very important to keep in mind here. That there is no. Sorry, this is not going to be any. There's not going to be any. There we go. There's no carbon tax, and thereby no abatement in this specification. So here we see only the effects from the climate change onto the economy. Okay? That's how you have to interpret this. So let's try to locate where is this showing up? Where is the where's climate change showing up in this in this economy now? Can we try to locate that? Okay. Well, I think the easiest one is we're going to have that carbon emissions or that accumulation constraint. So we're going to see the carbon emissions being accumulated, and we see that it's been driven by this accumulation constraint. But notice there's no mu in here. That mu is equal to 0 in all periods in time. Right? There's no abatement. That's why mu doesn't show up here. There's no change in the monetary policy part. That's interesting, no? I mean, not interesting, but per se, it doesn't change the equation of monetary policy. It does change the term for marginal cost. It does change the term for marginal cost. There we go. So those are, at least in my view, those are the only changes that carbon damages do to this model economy.
So for this whole thing only capture the climate inflation?
Yeah. You are always ahead of us. I mean, I'm going to go exactly to that. Okay, so this is, when, and I'm not going to give away that buzzword yet, right? So, but this is when you only add, climate change to the economy. These are the only changes that you're going to see in this economy. Now let's try to see and get to where Min is already in his mind. Let's try to understand what does this do to the economy. Okay? What is the effect that this has on the economy? And we can already see that. Like for instance, if output production increases emissions and increases the stock. Okay, so let's think about like, we have more output being produced, and that drives via emissions, drives up the stock of carbon in the atmosphere. What's going to happen elsewhere in the model? Well, the only thing that's going to be affected is marginal cost. The reason is, why is this now affecting marginal cost? Well, you can think about it, it's adversely affecting the productivity of the firm. Right? For a given amount of inputs, then it's going to be producing less output. That's how you have to think about it. So in terms of, let's go back to, if you go back to our other slides from Monday or Tuesday, you know how we defined marginal cost? Right? We defined marginal cost as W, the nominal wage, divided by productivity, right?
Yeah.
That's how we defined marginal cost here. Right? But now marginal cost carry this additional climate inefficiency or this climate damage part, right? And that is now just phi of m tilde t, right? And so, we need to divide this, of course. Let's go in the denominator. Goes in the denominator, so now we have phi of m tilde t here, right? So there's now an additional element in here, and we know that if m goes up, right, this thing falls, and so marginal costs go up. That's the key idea, right? So if m goes up in this function inside, we learned that by the functional form, the function itself goes down, and marginal cost is going to shoot up. That's the key idea. So where do we see this on our equations here, right? Where do we see this on our equations? We see this right here. There is when m goes up, we have more emissions, the phi goes down, and you say, wait a second, that's the wrong direction, right?
The minus.
There's the minus sign. You guys have good eyes, okay? There is, of course, this minus sign, so this entire term here, of course, goes up. And that's exactly what Min said a minute ago, or two. That's the climateflation channel that Isabel Schnabel and her colleagues talk about when they talk about climateflation. So let's go back here to the very first slide. That is exactly the climateflation channel that central bankers have in mind. So let's go there and let's annotate that in our slides. So this is the so-called climateflation channel. So this is quote-unquote climateflation. Right? And we can expect then, of course, because marginal costs are higher, right? Marginal cost increasing, inflation is going to go up. Okay? Inflation will increase. That is the key idea. So to the extent that climate change increases emissions, we're going to see higher marginal cost by firms, and that's going to produce more inflation. Now notice, there is this very important but subtle distinction how to interpret the climate change. I mean, there are scientists that say climate change is primarily driven by human activity, by production, and there's other scientists who oppose that view and say, it is, we have climate change not because of human activity, because the planet itself, has these big long waves of heating up and not heating up. Okay? So how does that type of debate fall into here? Right? So it's perfectly consistent to think about that, there are objects like trends in decoupling, or maybe very persistent exogenous emission forces. Like if you think about, another way to think about this epsilon is also an eruption of a volcano. that falls into this epsilon E. Right? An eruption of a volcano produces more emissions. It has nothing to do with mankind or human, production activity. So you can use this model to think about this in a broader perspective, saying, look, climate change according to the model is possibly driven by, or is driven by production activity, but there are also exogenous forces outside the human production, so to say, emissions that lead to more emissions. Regardless of the precise source, in both cases, we're going to see higher marginal costs for firms. So if volcanoes keep on exploding and whatever, firms are going to have higher costs, and that's going to produce more inflation. And then of course, right, once we have more inflation, that makes the life of a central banker a hell, right? Because we have higher inflation now, costs gone up. What does the central bank now do? And that we're going to learn that starts to look a little more like a cost push type shock. Because prices are going to go up, inflation goes up. Now guess what the customers are going to do? They're going to buy fewer output goods because they became more expensive. And so this is more like a cost push shock that provides a dilemma for the central bank, right? So that's the key idea. So if I can ask you for one thing, don't interpret this work as, entirely signing on to the idea climate change must be mankind-made 100%. It's one interpretation of the model, but you can use the model also to study what happens if there is an exogenous increase of emissions. A master thesis could do that. You could examine that. You would parameterize this. You could think about, okay, let's take this out here and have this completely exogenous, right? How would climate change affect monetary policy? And then you say, look, you contrast that to how would climate change, if it's man-made, at least to some degree, affect the economy? You compare those cases. These authors don't do that, but the model is perfectly fine to be used for that type of analysis. Now, honestly, I don't want you to perceive me as a climate change denier. I'm not. I think we are living in a world with climate change, and I do believe mankind has contributed to it. But there is a chance by how much mankind has contributed to it to maybe have a more nuanced analysis and discussion. I think that's a fair way to think about possibly what's going on. How much man-made or mankind-made, climate change actually contributes to climate change. It's undoubtedly we do, but by how much I think that's something that's still under researched, at least in macroeconomics, in the field of macro climate change. Wonderful. Any questions? And even if you're living in an economy where the economy, like if you're living in the US right now, for instance, the United States, and the current government just denies that climate change is man-made or mankind-made, you can still use a framework like this to understand, well, climate change does happen, and if you think about it, it's not human-made. Where does it come from, and how does it affect inflation going forward nevertheless? That's the key. You will not have that two-way interaction, right? Because here, if it's man-made, man-made production is producing more emissions is producing more inflation. The central bank does something, may cool down the economy and tries to reduce this, right? But that two-way interaction is going to be gone, but you could still start analyzing what's going on otherwise. All right. Any questions to this? This is the first key result from this paper. Even though we haven't seen any numbers yet, but this is the first key result. All right. Now then let's move forward. So this slide is just tagging on stuff to the previous slide, so we don't have to discuss it. It just gives you more information on this and talks about the climate changes. So these are I've said all this in words, right? And now on slide 21, this is the full carbon model. Now this is the full carbon and macro climate model. Okay, so this is the full model that we have, that now includes mitigation policies as a carbon tax. Okay, so this is the previous version of the model with climate change only, and now adding carbon taxes. Okay, this is now, this is the quote-unquote full NK climate model. So that now has the taxes added to it. And there's 3 places where these taxes show up. And let's maybe start first. The first place where the tax shows up is at the bottom here, right? Is at the climate, at the carbon accumulation constraint. Right? And so now we have this additional term where this is equal to mu. Okay? So this is equal to mu t. There. This is equal to mu t. Right? So this is the abatement share, right? That is chosen now optimally. Now your eyes are going to say immediately, this looks different when we derived, right? I mean, this thing looks different than our formula for mu. Let's go back. Our formula for mu looked much more complicated, right? Our formula for mu looked much more complicated than what they have in their formula there. So what's going on? Where's the difference come from, right? Well, you got to be very careful. Let me zoom up. There's a little twiddle there. There's a little twiddle there. So this is a transformed, mu. Okay? So in other words, there's a transformation that they did. This is still equal to mu, but the tau has a transformation. Okay, so for that you need to go hunting. Well, let me show where you have to go hunting. So you go to their paper. You open their paper, right, on Moodle, and once you have that paper, you're going to go to the appendix of the paper. So you go to the appendix of the paper, that's at the very end, right? And at that very end, now let me find it. If you go to page number, no, this was already too far. It was in appendix A. There we go. There we go. Okay, if you go to appendix A of the paper, on page 46, okay, so this is, or it's PDF, page 43. Okay. If you go there you will find the definition of mu tilde, of theta tilde, which is this one here. Yeah. And if you use that, right, so you take that, it's nothing else as a redefinition, if you like. So they're folding everything in theta tilde, make that a stationary object, right? This is the original theta, carbon tax, times the trends, and those 2 trends basically induce that the resulting theta to be stationary. So you take that equation, you take this, and you plug it into our formula for mu, you're going to get their equation, on the slides. That's the key. So take this equation from 43 and plug that into the formula that we have, and that will give you exactly the formula. Can somebody memorize that? Well, you do this at yourself. I mean, let's not waste too much time here. But plug that in there, and you're going to see you get exactly the equation that we derived. All right. Long story short, there is abatement now here. Okay, that's the first time thing that shows up. So and again, if the tax is 0, we're going to be back to the climateflation world only. But if the tax is non-zero, you're going to reduce the emissions. Okay, so you're going to reduce the additions to the stock. That's how to correctly say it. Okay, so you're reducing the emissions to the stock of carbon. All right, so that's the first change. Now you have to be careful because where else is this showing up? And it's going to show up here, right? It's going to show up in the resource constraint. And those are now the mitigation expenditures. It's an expenditure. And think about, I like to always think about it like this. If you put this onto the other side, right? What this says is that you have, literally speaking, that you have consumption plus abatement spending or mitigation spending, plus adjustment costs plus is equal to output. That's what this equation says. Okay? So they write it in a little funny way with all these minus signs, right? But if you bring all these objects to the other side, what this means is that all the output produced in this economy can be used for consumption spending, for mitigation spending, right? Spending on new, and then plus, and those are all the adjustment costs. So this is the adjustment cost for prices for the firms that survive, that do not exit, right? This is the Rothenberg costs that the firms have for adjusting their prices. And these are, the firms exiting, is the profits, so to say, that these firms, generate that are lost. And so that's a spending on like the exiting entrepreneurs, they just eat up those profits. So long story short, you can think about this as the aggregate resource constraint. And of course, when you have mitigation spending, that's going to crowd out a little bit of consumption spending. Now firms spending on mitigation, the customers, the consumers, going to have less possibilities to consume, right? Because there's another demand, namely the demand component for mitigation spending. All right. So that's the second element that shows up. And now we have one more element showing up here, which is now this one. There we go. Right? And this is now the marginal cost term for the carbon tax. Now again, this is now in rescaled tau twiddle objects there, so there's a little bit of a rewriting issue, but intuitively, this is the marginal cost contribution that firms have because of their spending on carbon taxes. I think it's pretty obvious to think that now when firms spend, provided tau E is non-zero, right, this tau is non-zero, right? Of course, if it's zero, there's no effect on marginal cost. But if tau is non-zero, you're going to have spending effects that on firms for their carbon tax bill. It's like the labor bill, right? And so if tau is positive, it's increasing marginal cost. Now, let me ask you, so this is the full model. We've seen that in the model without any carbon taxes, we can identify the climate-flation channel, right? On the very first slide of this slide deck, I talked about the climate-flation channel, and I also talked about that there is a greenflation channel that central bankers are worried about as well, right? Given the full model that we just developed, given the full, New Keynesian climate model, where would you identify, and maybe give other people a chance to answer that question, where would you identify the greenflation channel of climate change in this version of the model? Somebody think about that. Where would you think greenflation is going to show up?
Carbon tax.
What's that?
Carbon tax cost.
The carbon tax, right? The carbon tax is now the greenflation channel. And it is this one. This is the greenflation channel. Right? So that is now the greenflation. Greenflation channel. And we're going to develop intuition for that, of course, channel in a second, right? So we said, maybe remind yourselves, we said before, right, this is the climate-flation channel. So before we said this is the climate-flation channel. This is climate-flation. And now we have a greenflation. So the climate inflation channel was again, if you have more spending, you have more economic activity, you drive up emissions, the carbon stock goes up. That's going to increase this object in the marginal cost term, right? And driving up marginal cost, driving up inflation. That was the climate-flation channel. We understand that. Now, when the government, in an effort to reduce emissions, levies on a tax, well, guess what that tax is going to do to firms' marginal costs? Firms' marginal costs are going to go up. Right? So the marginal cost term now goes up for two reasons. For the standard climate-flation channel, but for the greenflation. Greenflation meaning you want to have this economy going into a green transition mode, That would be like, fossil fuel free production or less fossil fuel production. The tax, of course, the tax is going to reduce the emissions. That, right? I mean, the new emissions are going to get reduced. The higher the tax, the higher is mu. So we're going to reduce the new emissions. That thing is going to be smaller, right? But it comes at a cost. That this additional spending, right, on mitigation is going to produce higher marginal cost, and that's going to, lift up inflation additionally to the climate inflation. That is a key here. So there's now two full channels at work by which this is going to change. Can you say it again? One has to balance it. Well, exactly. And that's what we're going to do tomorrow. Okay. So the rest of this paper now is asking, how much does this matter quantitatively? Right. So far, we're looking at these equations, and we have now developed a model that can be used to talk to Isabel Schnabel, can talk to Jerome Powell, to talk to Christine Lagarde about, you may have greenflation or climateflation. Either case, it's going to push up inflation. And what these policymakers are going to ask you in return is saying, how much? This is entirely qualitative so far. There's we don't know whether inflation goes up by 0.5% or by 2% or by 10%. Okay. And that's the rest of the paper. The rest of the paper is now trying to quantify in a serious way by how much do these two channels affect the economy quantitatively. And that's the remaining part of the paper. Okay. And we're not going to start with that today, right? But that's the plan for tomorrow. In terms of, in this paper, we're now in the first step, and we're going to, be a consumer to that. We're going to learn how they pin down the parameter, and then how they are studying what does climate change, what does climateflation, greenflation do quantitatively to the economy. That's the key. And we will do that, then. Are there any questions regarding the model stuff?
Sorry for the greenflation.
Yeah.
Initially, you say, it can be a mix between the demand and the cost book side, right? And in here I see the tower is actually entering on both the IS inflation
Yes.
and the PC.
That's right.
So it's similar.
Yes. So it produces higher costs, absolutely, right? But it also crowds out private spending. I mean, think about what is abatement spending. It's a spending that firms go on there's total output that's produced. And before abatement spending, the only demand for this total output comes from consumers for their consumption purposes. Now the firms are showing up and they buy part of the aggregate output in the economy to do their abatements. Okay, so there's a second form of spending, right? There is a second form of spending now. There's not just consumption spending, but there is mitigation spending. And so there is a crowding out effect there. And that crowding out effect is, in other words, but it's not going to be complete crowding out, right? Private consumption is going to go down a little bit relative to the no abatement case, but overall there's going to be more spending. Meaning there is another demand force by which inflation goes up. Right? So the greenflation has both. It's the in general equilibrium, it's the increase in marginal cost that drives inflation. But of course, in general equilibrium, right, it's the taxes that generate additional demand in the economy that produce more inflation. Very good, folks. Other questions? So what we want to do in the next 15 minutes, we want to start working with the computer. It's a good time to, get going on working on this quantitatively. And what we're going to start with is, I don't know whether we're going to get here today in solving this model on the computer. Right? We will do this tomorrow morning for sure. But I want everybody to fire up MATLAB, open your MATLAB. And I want everybody to run the code that I know works, and we can check who has error messages to make sure everybody can run the codes that we have online. Okay? So the first exercise that we are doing here in terms of coding or running computer codes is you go to Moodle, okay? And on Moodle, I want to start with the file called nk.mod. I want to start with that file, nk.mod. That's going to be the first file that we want to be running. And maybe let me remind you, what does this nk.mod file do? Well, you go to our lectures from Monday, Tuesday, and we had this system of equations on Monday, Tuesday, this one here, right? So this was the basic canonical New Keynesian model, right? I coded this one up in nk.mod, okay? And I want everybody to open that nk.mod, and we want to run it together, and we want to understand what it does, what it produces, and then also what the solver does, okay? And then once we did this, I think we're going to call it a day for today, and tomorrow we're going to work with the code that I uploaded this morning, which is going to be the New Keynesian climate model. On the slide we literally study together. Okay. That's what we're going to then run tomorrow morning. Okay. So everyone, open a MATLAB session, please. And in that MATLAB session, let's go and let's see. I want to bring everybody up to speed in the sense of we have how to run these codes. Okay? So I'm sharing my screen, and I'm gonna move over a little bit here so that I can point on my screen as well as talk to you guys what we're doing. Okay? Good. So please open a MATLAB session, okay? And the first thing I would like you to ask is, do you know how to open the mod file in MATLAB? So, this is my MATLAB, window, and when I open nk.mod from Moodle, you should have opened this window inside MATLAB, okay? And the file starts with canonical New Keynesian model. Can you please open, and can you tell me, every time something doesn't work, you need to immediately notify me. I want everybody to be able to run these codes. Because if you're able to run these codes, the chances are high you will be able to run the climate model codes. So first of all, please open this mod file and let me know who has opened this mod file. Min has, Anne has, perfect. Ivy has. Open this mod file, please. And if you have trouble doing so, then let me know. I can. Okay, so the way to do this typically is in MATLAB, right? This is when you open MATLAB blank and you don't have any, mod file open. You go to, you can use this browser. To browse to the folder where the mod file sits. Okay? So in my case, you can use these here. You can click on this one. In my case, this file. Let's see. No, it's actually not here. Codes. I see. It's here. Okay, so I have it sitting in this folder, and then you just double click on this .mod file, and it's going to open that .mod file. Me? Perfect. One, how about you? Can you open the mod file?
I'm still.
You're still doing it? Okay. Two, how about you? Let's see. Okay. So you have downloaded that, right? And now you need to, wait, this is in your downloads folder? Okay, then you go into MATLAB, and you cancel this, cancel. And then you are going to go to the admin, and there it must be here down. So Anne, for instance, right, in her case, it's in her downloads folder. So then what you need to do is you need to, when your computer automatically downloads to your downloads folder, you click on your user, it was admin in her case, and then you look for your downloads folder, and you double click into the downloads folder, and then you open the one file. Okay. All right, good, we got this one. How about Anne? How about you? Are you able to open the mod file? Very good. Juan, how about you? You have it? Dean?
Yeah.
Great. How about here? Lynn, are you open? Perfect. And Juan? How about you? Are you trying to open it? Do you have MATLAB installed? Oh, you're still... You need to install MATLAB. That's going to be important. Could you work with Lynn for the next 10 minutes, but tomorrow, Juan, I would really like to ask you, try, you need MATLAB. You're going to work with MATLAB. It's also going to be exam relevant. Okay? So maybe you could work with Lynn for the next 10 minutes. Okay, so that's the first thing to do. Next thing is, you need to have Dynere, okay, in your computers, right? We need both MATLAB as well as Dynere, okay? Because Dynere, the mod file is a Dynere file. And it's a different, Dynere works within MATLAB, right? But it is a different computer program. So let me ask you, have you all installed Dynere? Who has installed Dynere? Who has not installed Dynere? Dean and Juan, have you installed Dynere?
I did.
You did not? Did you? Sorry.
I don't know.
You did? And Juan, have you?
Yeah,
have
I
you?
did.
So everybody has installed Dynere?
Yeah.
Wonderful.
And to find
Exactly. So that's what I'm going to explain next, right? We have to tell MATLAB where the Dynere installation sits. And think about MATLAB as having a telephone book in the background. And every time you do calculations with MATLAB, MATLAB is going to open the telephone book and it's going to look for, okay, Matthias wants to add two numbers, so the plus is a function. Where do I find the function that adds two numbers? So like, for instance, if I type 1 plus 1, and I hit enter in MATLAB, what MATLAB does in the background, it searches, does somebody know what the plus sign means? And if then somebody says, yeah, I do know what it is, then MATLAB sends this to this function, and it's going to compute the sum of two numbers. Okay? And Dynere is nothing else than a collection of functions, and we need to tell MATLAB where the Dynere installation is. Okay? And here's how this goes. If you go onto your MATLAB, there is this tab here. It's the Home tab. Okay? There's this first Home tab. Right? And there is a button that's called Set Path. There's a button that's called Set Path. Does everybody have that? Yeah? So that Set Path button, please hit that. If you hit that Set Path button, then you should have a user interface that looks like this. You should have a user interface that looks like this. Wait a second, I'm just going to clear it like that. So, does everybody have a window open that looks like this now? Who doesn't have that window? Is there somebody, be honest, I'm asking in a very direct way because I want to make sure everybody is on board. Is there somebody who doesn't have that, window? All right. So this is MATLAB's telephone book. Every entry here in this telephone book is telephone entries that, MATLAB asks, okay, I have 1 plus 1. My user wants to add two numbers with a plus. So is there, these are all the toolboxes, the functions that MATLAB, can use. And you need to have that telephone book in order to be able to do computations. And what we need to do is we need to add Dynere into this telephone book. That when we are typing, use Dynere with this file, MATLAB is going to go into the telephone book, it's going to ask, somebody know what Dynere means? Well, then we need to have an entry jumping up and say, yeah, I do know what Dynere means. Send this stuff to me and I'm going to take the computations. So how do you add Dynere? It's very easy. You click on this Add Folder button. Okay, there must be an Add Folder button on your computers. Don't use the Add with subfolders, use the Add Folders button. You click on that Add Folder. Okay. And that's going to open a user interface. Okay? And then you have to navigate to the place where you install your Dyneer. So on a Mac machine, it's under Applications, okay? And then in Applications, you're searching your Applications folder, and there's going to be one folder that's called Dyneer. You double click into that, and I have many installations of Dyneer on my computer, and you want to pick the 6.5 version. On a Windows computer, you go to C drive, you know, and from C drive you see a Dyneer folder installation.
Is this version 6.3 okay?
Should work as well. Yeah. So 6.3 should work. If you can work with 6.5 to more, because then we are working on the same MATLAB Dyneer version. So today is totally fine. But okay. So then, does everybody can everybody see Dyneer? Okay, perfect. So then what you do is, now comes the important thing. I double click into the Dyneer version I want to work with, 6.5. Double click into this. And then, now it's important. You're going to locate, don't double click. You're going to locate a folder that's named MATLAB. And then you mark it. You're not double clicking into it. You just mark it. Okay? You highlight it with the one click. And then you're going to hit open. And you're going to hit open. And then, the proof of the pudding, whether you did this correctly, is that in this telephone book, you have now an entry at the top that says, go to Applications, Dyneer 6.5 MATLAB. And in that folder MATLAB, there's like hundreds of MATLAB files that the Dyneer team has written that do all the computations we're going to need. So let me know who has successfully added that to your path. Lynn, perfect. Dean, everybody? You guys are great. Good. Excellent. Now, you need to do this only once in your life or in the lifespan of your computer if you hit save. Then, tomorrow, if you reopen MATLAB, you know, this entry will stay there. You don't need to redo it tomorrow morning. Okay? So when you hit save, then this entry will get saved. When you hit close without saving, then you have to do this tomorrow morning again. Okay? So I advise you to hit save. Okay? And then we are almost ready to go. Now you hit close, and now we have Dyneer in this MATLAB installation. And before we look at this file, okay, what this file does, let's try that everybody can run this file. Okay? And the way you run this file is you're going to type in Dyneer blank nk.mod semicolon. That is the command. Dyneer says to MATLAB, call the Dyneer functions. And then MATLAB says in its tree, in its telephone book, is there any Dyneer functions? Do you know anything? And then the Dyneer functions say, yes, we do. And then you're sending this file to the Dyneer functions, and Dyneer works with this file. Bless you. And then you hit enter. Okay. So you hit enter, and you should see computations here, and you should see two figures popping up. Okay. And then once the second figure has opened, you know, the computations here should start, and you should see these two forward triangulars. Okay? So that's the goal that you should have. Now let me know who has these pictures. And you have an issue there. Okay. Oh, good. Anne works on a Windows machine, and Anne doesn't have a save button, but she has a tick box that says save path for future sessions. Here we go. And then you say okay. Okay, so if you're on a Windows machine and you don't have that save button for the path, use for future versions there. Great. 2 has the MPs. Oan is working on it. I'll help you in a second. Dean is working on it. Min has it. Lynn is working on it. Get to that in a second. And oh, perfect. Ivy has it as well. So let me try to find what's going on. Let's start over here. Type Dyneer nk.mod. This looks very promising. Very good. Great. Okay. Wonderful, Oan. Great. Fantastic. So, Dean, let's see. What do you get here? change the extension of the file name. There we go. Let's pause. We have this. Enter. And then to double click on it because it's still as a text file. There we go. And now we will run it here. This looks very good. Excellent. Making great progress here. Lynn, wonderful, great. Everybody got it. That's fantastic. Okay. So we understand, you can run these mod files and it produces the impulse responses that you have on the slides in our slide deck, 2 and 3, right? So these are the impulse responses to the technology shock that we discussed, and these are the impulse responses to the monetary policy shock that we discussed at length, okay? And the mod file has this coded up, and I think this is a great time to stop today, and then tomorrow morning we will take some time to review the contents of this file, and I will focus in particular on the $1 million command here, which solves and simulates the model with the guess and verify, the linear solution. And then in the second part of tomorrow morning, we will be, working with the macro climate model codes and examine what the solver there is and how the solution works and so forth and so forth. Okay, so that's the basic idea. So I want us to set up this, and then we will be playing with the codes, change parameters, rerun the code to familiarize ourselves. Maybe we can work toward isolating the climate-flation effect versus the greenflation effect tomorrow. Okay, so that's going to be the game plan until tomorrow. So bring your computers as today, and then we're going to have at least a 90-minute coding session tomorrow, the first session. Okay, we will be spending enough time to familiarize ourselves with these codes, working with them. And it would be great if you could install MATLAB in there. Yeah, maybe you could. Exactly. Perfect. You could ask maybe your fellow students on how to do it in case you're struggling. Great. Enjoy the afternoon. It's been great seeing you. I'm looking very much forward to more in continuing our course. Thank you. Thank you, everyone.
Thank you, Professor.
All right. Perfect.